So in this example, three boy A, B, C are situated at the vertices of the equilateral triangle of side D. Right, at t is equal to 0, each of the boys move with constant speed v. A always move towards B and B always move towards C and C towards A. When and where they will meet, right, each other, right? So this is the very common questions, right? For example, we have a triangle like this, right? This is the person A, person B and person C. Every person is on equilateral triangle and the side of the equilateral triangle is what? Suppose it is D, right? The side is D. Now the person A C towards B, right? And the person B towards C and C towards A, like this. So after some time they will be again at the vertices of the equilateral triangle, right? After that the B is over there, so the AC in this direction, right? BC in this direction, AC in this direction, right? Again they will be on the vertices of the equilateral triangle. This is on this direction, right? This is on this direction. Again they will form an equilateral triangle. Always they will be on the vertices of a equilateral triangle. Are you getting or not? It sees in this way, it sees in this way, it sees in this way, right? Again they are on the vertices of the equilateral triangle. So finally they will meet like this, they will meet like this, they will meet at the center of the, at the centroid of the triangle, or the center of the triangle they will meet. Is it clear or not? So the question is where they will meet. They will meet at the center of the centroid of the equilateral triangle, right? And what time they will take, right? To find this, listen one thing. Actually what is happening, the initial side of the equilateral triangle is D. When they reaches at this point, right, they again forming the equilateral triangle, they again forming the equilateral triangle, again forming the equilateral triangle, again forming the equilateral triangle. So the side of the equilateral triangle is continuously decreasing. So if this angle is 60 degree, this is the V and this is the V, right? So if you resolve this, this is the V cos theta, V cos theta, V cos 60 is equal to what? Say V into 1 by 2 is equal to V by 2. So this velocity component is V by 2 and this component is V sin 60 is equal to V root 3 by 2. Is it clear or not? So if you consider the two velocities V by 2 and V by 2, so if you consider this is the C or B, right? So both are coming towards each other by what is the relative velocity? You tell. V by 2 and it is VB. If two particles is moving with V and this is the V by 2 and the separation between them is D. So this separation is decreasing. This separation between the two particle, or you can say the side of the equilateral triangle, is decreasing. By what rate? By relative velocity. It is V by 2 plus V is equal to 3V by 2. So this separation is decreasing, this separation is decreasing, decreasing, and finally when they will meet, the separation between the two particles or every particle becomes 0. So the S is equal to UT. What is the distance? The distance between the two particles is D, and what is their relative velocity by which this separation is decreasing is 3B by 2 into T. So this is the total time taken when they will meet at the center is 2D upon 3B. Understood? So this question can be solved with the help of the relative motion easily, right? Copy this. So similarly, we can take another illustration. For example, suppose there are four particles, right? This is the A, B, C and D, and they are C and D. The four particles are, they are moving towards each other as we did in the previous case, towards each other, and this is the square, and the side of the square is what? So you will say it is D. Is it clear or not? So every particle sees towards next to it, the next particle. A is seeing towards B, B towards C, C, D and D towards A. When it reached the B over here, so it move in this way. it move in this way and it move in this way, right? Like this, and it move in this way, right? So you tell me. Again, they are on the corner of the square. It move in this way, it move in this way, it move in this way, it move in this way. So A sees towards B, B sees towards C sees towards D, and D sees towards A. Again, they are on the four corner of the right square, like this, right? Like this. So the always they are on the side of the square, and the side of the square is continuously decreasing. Is it clear or not? And finally they will meet at the center like this, right? They will meet at the center, right? After some time they will meet at the center. So what is the time? To find the time, right, you consider any two particles. It is the velocity v and the velocity v. When they are, the initial separation between them is what? Say d. And this separation is decreasing, and finally becomes zero. So can you tell me what is the relative velocity by which this distance is decreasing? This is the v always, and this is the v. So what is its component in this direction? Nothing, zero. So what is the relative velocity? What is the relative velocity along this line, or by which this distance of the square, the side of the square, is decreasing? The relative velocity is v only, right? So s is equal to what? Say ut. So d is equal to v into t. So what is the time after which they will meet? So the time is t is equal to d upon v. Is it clear? Copy this. So very similar other example, right? Suppose now the six particles are there, right? And six particles are on the six side of hexagon, right? Suppose there are six particles and the side of the hexagon is D. This is A, B, C, D, E and F. Again, they are moving towards each other, right? And where they will meet? Definitely at the center. How? This is the V, this is the V, V, D towards E, towards F, towards A. All right. So again, they are on the sixth corner of the hexagon like this. Is it clear or not, you tell? Then again, B, C towards A, B towards C, C towards D, D towards E, E towards F, F towards A. Again, they are forming the sixth corner of the hexagon. Is it clear? Again, it is like this, like this. They are always looking towards the next particle to each particle like this. So what is happening, you tell? What is happening? The side of the hexagon is decreasing, right? And finally, when they will meet like this, 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 they will meet like this. So six particles will meet at the center of the hexagon, and the side of the hexagon, the size or side of the hexagon is decreasing. By what rate? Let's see. Listen one thing. How to solve this? Suppose this is the hexagon, all right? This is the and this is the center. Is it clear or not? This is the center. Fine. So if this is the v velocity and this is also the v velocity, is it clear or not? So you tell me, yes, you tell me, what is the angle? What is the angle? The angle, this every angle is what? 60 degrees. So this is 60 degree, 60 degree, 60 degree or not, you tell. Right? If you consider this is the two particle, this is also the 60 degree and this is also the 60. Every angle you are looking is 60 degrees, 60 degree. Right? Is it clear or not? Now you consider these two particles. Right? I am writing here. So the two particles and the separation between them is initial d. Right? And this is the v. And this velocity is v. right? This is 60 degree. Is it clear or not? Right. This is the V, and this velocity is what? Say V cos 60. What is the value of V cos 60 is equal to V by 2, right? And this is what? V sin 60, which is equal to what? Say V root 3 by 2. Now you tell me, if these are the 2 points, right? This is the velocity V and this is the velocity V. So this separation is D. By what relative velocity this separation is decreasing? You tell. Both are in the same direction. So when they are moving in the same direction, the relative velocity decreases and subtracted. So V minus V by 2. I think you understand this. The relative velocity. So S is equal to ut, time is equal to distance upon u. What is the distance? What is the separation between each particle initial? Say d. And what is the relative velocity? Say v by 2. So the time after which they will meet at the center of the hexagon is 2d upon v, right? Copy this. So this is the next question, and this is the questions of the relative motion in plane. This is the very important and the easy question. Let's see. Two particles A and B are projected from the ground simultaneously. The direction is shown in the figure. The velocity of A is 20 meter per second and VV is vertically upward, right, 10 meter per second. They collide after 0.5 second. You have to find the angle theta and the distance x, right? This is the question. So in this example, for example, if we see, right, if this is the particle, right, B, and it is the velocity initial 10 meter per second, that initial separation is x, and they are thrown with the speed 20 meter per second, all right. They are thrown in the air, although it will move like this, right, and it will move like this. So they will hit each other. Is it clear or not? You tell me. When they are moving in the air, right, when they are moving in the air, what is their acceleration? The both have the same acceleration, a minus g, right? If you consider this the x-axis, the y-axis. And what is the acceleration of b? The acceleration of b is also g into minus j cap. So what is the relative acceleration? The relative acceleration will be aa minus ab, right? Or ab minus a. So the relative acceleration magnitude is what? 0. So no relative acceleration first of all. Is it clear or not? Now see, you may sit on the A and you may sit on the B. It is better to sit on the B with respect to B. This is the figure with respect to ground you have made. All right. Now you can make the figure with respect to B. With respect to B. When you make the figure with respect to B, is it clear or not? So this component is what? Say 20 cos theta, and this component is what? Say 20 sin theta. Is it clear or not? So if you consider this is the with respect to B, or so B is at rest, B is at rest, right? So its velocity, if you are at B and looking at A, so initial velocity is what? Say 20 sin theta, and it is 20 cos theta. Is it clear? And listen one thing, and what is the velocity of the B is 10 meter per second. With respect to B, what will happen? It is transferred to 10. To this velocity is transferred in opposite direction to A, 10 meter per second. Is it clear or not? You tell. Now A must be collide with B. So what is the condition? You tell. What is the condition? If A must be collide with E, so in which direction the particle A should move? You tell. It must move in the line joining A and B. Are you getting or not? So therefore the condition is that it has only this velocity and the no velocity in this direction with respect to B, right? So therefore in Y direction, condition to collide with B, what is the condition? This component must be 0. The Y component must be 0. that is tan must be equal to 20 sin theta. So what is the sin theta, you tell? Say tan upon 20 is equal to 1 by 2. It is equal to sin 30 degree, and theta must be equal to 30 degree. So the theta must be equal to 30 degree, right? If theta is must be 30 degree, right? And what after what time they collide? It is given in the question, and it is equal to 0.5 second, right? So now with respect to B, this is the B and this is the A, and it is coming towards B, right? With what speed? Say 20 cos 30 is equal to tan root 3, right? Root 3 by 2. So, and this distance is x. So after what time? X is equal to u into t. So what is the relative velocity? The distance is x. The relative velocity is tan root 3. And what is the time? Say 0.5. 5 root 3. Right. So what should be the separation between them? This is 5 root 3 meter. Is it clear or not? Right. This is the one way to solve this question. Right. The another way. Look at the figure. The another way is that if there are two particles, right, it is moving with V1, it is moving with V2, and the theta is angle. So this is the V2 cos theta and this is V2 sin theta. Is it clear or not? You tell. So when it is moving in this way, it is moving in this way. So after some time, what will happen? To move so the collision is occur. So what is the thing, right? What is the condition? The condition is that when it is at this point, so the particle must be, this particle must be at this point, right? When it reaches to the B, suppose this is the A and this is B. So when reaches at this point, it must be this point, reaches at this point, at this point, reaches at this point, and when they hit like this. What is the condition? Condition to hit is that the vertical component, right, perpendicular component of velocity must be same. Is it clear or not? So therefore, what is the condition? V1 and V2 sin theta implies that V2 sin theta must be equal to V1. So this is the component, their vertical displacement must be same, and the horizontal and the separation, perpendicular separation, or this separation must decreasing, and this is the V2 cos theta. So by what rate they are decreasing this separation, right? So if this is the distance x, after what time they will hit? X is equal to ut. So time is equal to distance upon u. So the separation is x, and the relative velocity is v2 cos theta. Is it clear or not? Right. So if this is 20 sin theta and this is 10, so condition to hit for the collision, the vertical component must be same. So therefore sin theta is equal to what? This is equal to 1 by 2 is equal to sin 30. So therefore angle must be equal to 30 degree. And when the 30 degree known, you can find this velocity, and the separation you have to find, while the time between the collision is 0.5 second, right? You can copy this. So we can take few more examples. For example, listen one thing. Suppose these are the two particles. They are thrown vertical upward direction from the ground, because their relative acceleration is 0. Right. If suppose this is the particle A, the particle B, this is angle alpha, this is angle beta, and the initial separation is D. Right. This is the V1, this is the V2. So what you have to find? You have to find the condition to for collision, right? For collision, so that both can collide. Also find the time, right, when they hit each other or when they collide. So as I told you, whether they are in the horizontal plane, right, or they are in the vertical plane. In the vertical plane, their relative acceleration is 0. So what is the condition to hit? listen one thing. This is the V1 cos beta, right? And this is the V1 sin beta. This is the V2 sin alpha. This is V2 cos alpha. Is it clear or not? You tell. So the condition is that their vertical displacement must be always same and the separation must be decreasing, right? The initial separation. So what is the condition? Condition for collision, right? Condition of for collision that their vertical displacement must be same, or therefore the vertical component of the velocity v1 sin beta must be equal to v2 sin alpha, right? They will give some numerical value and you can put accordingly and you can get the answer. And second thing, what is the relative velocity by which this distance is decreasing? This is the b and this is the a. This is the v1 cos beta, this is v2 cos alpha. What is the separation? D. So what is the relative velocity? U tell. Is equal to v1 cos beta plus v2 cos alpha. You can say when both are in opposite direction they are added, right? Or you can do in this way. With respect to b, you may sit on b. So b is at what? With respect to b, v is at rest. And what is the a velocity? Say v1 cos beta, right? And this is the v2 cos alpha. It is transferred to a in opposite direction. So this is the v1 cos beta plus v2 cos alpha. So by what velocity suppose it is to be at rest and the a is coming with what velocity? v1 cos beta plus v2 cos alpha. So it will hit like this. Is it clear or not? Getting? And listen one thing, if v2 sin alpha is there, so v2 sin alpha will cancel out the v1 sin beta. So only the velocity will be along the line. So if this is the d, so what is the time? So distance upon the velocity. What velocity? Relative velocity. You can also write directly if they are moving in opposite direction, the relative velocity is added, right? So d is equal to what? v1 cos beta plus v2 cos alpha. Is it clear or not? Right. So this is the total time after which they will meet, right? Also one thing, this expression can also be used to find the velocity. Suppose this is the v2. So v2 value is what? Say v1 sin beta upon sin alpha. So if suppose the v1 is only given in the question, right? So the v2 value I will put v1 sin beta upon sin alpha into cos alpha. Although this is the answer, but in terms of v1 only, d, you take v1 common and this is the cos beta plus sin beta cos alpha upon sin alpha. When you will simplify, it goes in the numerator, right? And it is multiply sin alpha cos beta plus cos alpha sin beta. Fine. And this is the v1. This is the total time. It becomes sin alpha plus beta, right? I am writing this side. So the total time is d sin beta, right? D sin alpha. This is d sin alpha upon v1. This is sin alpha plus beta. Is it clear or not? Sin a plus b ka formula it is, right? So time is equal to d sin alpha upon v1 sin alpha into alpha plus beta. So this is the answer, right? Copy this. So in this example, two particles are projected, right, from two towers simultaneously as shown in figure. And what should be the value of d so that for their collision, right? So the in this example, this is the 10 meter. The particle is, this is the particle A, right? It is thrown 10 root 2 meter per second at the angle 45 degree, right? And the another particle is on the tower of 20 meter, right? and this is the B, and it is thrown at angle with velocity 10 meter per second. Is it clear or not? So they have to collide. They will move like this, it will move like this, and they will collide. Is it clear? First, I will, they are asking the separation between them for collision. Is it clear? So first I will discuss, I will check whether what is the horizontal and the vertical component. So this is tan root 2 cos 45. 45 value is 1 by root 2. So it is tan root 2 into 1 by root 2. So it is 10 meter per second. In the same way, this component is tan sine 45 and tan root 2 sine 45. Sine 45. Sine 45 value is 1 by root 2. It is 10 meter per second. Is it clear or not? So also listen one thing, when it is moving, right, the acceleration of A and acceleration of B is what? G downward, right? So therefore the relative acceleration between them is what? 0. So now you can make the figure once again. This is the D, this is the 10 meter, this is the velocity 10 meter per second, this of the B, and this is the velocity of A, right? 10 meter per second this side, 10 meter per second this side. Is it clear or not? You tell. Right. So you tell me, what is the condition? Although this is the velocities with respect to ground, is it clear or not? So you may sit on any of the particle and you can write the relative velocities. You tell me on which particle you want to sit. Suppose with respect to A, you make the figure. So if you are making the figure with respect to A, right? So A is at rest. A is at rest. And to find the relative velocity of B with respect to A, what you have to do? You will transfer this velocity in the opposite direction. Although B has itself the velocity 10 meter per second, this velocity is transferred in opposite direction. Is it clear? And this velocity is transferred horizontally in opposite direction. So this is the 10 meter per second. Is it clear or not? And this is the distance, right? This is 10 meter. You tell me, what is, if you consider this the A, right? You consider this the B. This is the 20 meter per second and this is the 10 meter per second. Are you getting? So this, for collision, you are sitting on A, it is at rest. So for collision to be occur, what is the condition? The condition is that the B must be coming towards the A. The relative acceleration of B with respect to A is 0 because both are in the same. So for the collision it must be come in this way. Is it clear or not? So, and they will hit. So if this is the distance D and this distance is 10 meter, right? So if you consider this the theta, so what is the tan theta you tell in this triangle? This is the perpendicular upon base. If this is theta, this is also theta. By this triangle, what is the tan theta value? Say perpendicular upon base. This is the perpendicular. Also, the tan theta may be written as perpendicular upon base. This perpendicular is what? Say 10, right? 10 upon 20 is equal to 1 by 2. So tan theta value is 1 by 2. So D must be equal to 20 meter. So the separation between them must be equal to what? 20 meter. Is it clear or not? Also, if they ask what is the time they will collide, if this is 20 meter, right, and this is 10 meter, right? So either you may write this is the vertical velocity, right, 10 meter, this is 20 meter. The vertical component of the velocity is what? 10 meter in y direction, right? You tell S is equal to ut. What is the displacement when it reaches, although this is the displacement, relative displacement, but in vertical direction, what is the distance it has to cover? 10. By what velocity it is covered? Say 10. So what is the time? So t is equal to 1 second. It is clear or not, you tell? Right? If you want to take the x direction, in x direction, what is the velocity? Say 20. What is the displacement in x direction? Say 20. So time is equal to what? 1 second. It means when it is thrown like this, it is thrown like this. So they will collide at this point with respect to ground. At what time? Say after 1 second. Is it clear or not? Copy this. So in this example, two boys standing at ends A and B on the ground, where AB is shown as shown, AB is equal to small a. Boy A start running in direction perpendicular to AB, right, with velocity v1. Boy A start running simultaneously with the speed v to catch the boy in time t. Then you have to find time t, right? For this question, suppose we have the A particle or the B boy or A boy like this. The separation between them is suppose the small a. The B start running v1 and the A start running in a straight line with speed v like this. Suppose at angle theta. When it is moving, when this boy is moving in this way, it is moving in this way. So they will catch each other, right? Listen one thing. What is the condition so that they may, this boy A can catch B? What is the condition? If this is the B, this is the B cos theta, right? And this is the V sin theta. Are you getting or not? So what is the condition so that they can meet? Their vertical direction, right? Their vertical displacement must be same. For example, sometime it reaches at this point. So the A must be at this point. If they must be in this direction, they must be at this line, they must be at this line, they must be at this line, and finally they will meet at this point, right? If the speed of the v1 is greater and A is less, so what will happen? So it will move like this and it will be so moving in this way. So it cannot catch. What is the condition? Condition to meet A and B. Tell me. What is the condition? Their vertical component, vertical displacement must be equal. Therefore, their vertical component of the A and vertical component of velocity of B must be same. What is the VA? V sin theta. And this is what only? V1. Is it clear or not? Right. So sin theta must be equal to what? Say V1 upon V. This is the one thing. Fine. Now, if the separation is A, they are asking after what time they will meet. If they find with respect to A, with respect to B, are you getting or not? If you make the figure with respect to B. So B is at rest and its velocity is transferred to this, the V sin theta, and this is the V1 and this is the V cos theta. So listen one thing. The condition for collision, as I already explained, that the person A must be running in this way so that it can collide with B. So V1 and V sin theta will cancel each other. Only the relative velocity is what? Say V cos theta. And the separation between them is what? D. So S is equal to UT I will apply. Time is equal to distance upon relative velocity. Distance is A. The relative velocity is V cos theta. Is it clear or not? So this is the V cos theta. Now, what is the theta is not given in the question. So I can write the cos theta is equal to 1 minus sin square theta. The time is equal to A upon V. The value of sin theta may be written as V1 square upon V1 upon V whole square. Right? It is equal to A V minus square square. You take the LCM, right? V square minus V1 square upon V square. So when it comes from the square root, it will cancel this. So the time is what? A upon root over V square minus V1 square. So this question is solved with the help of the relative motion. right? Copy this. So in this question, right, this is the very much similar to question we have discussed. A body is projected with speed u1 from point A, and at the same time another body is projected with the speed u2 from point B. What should be the value of u1 upon u2 so that they can collide, right? Okay, so in this case, suppose this is the A, this is the B, this is U2, and this is the U1, right? The angle is 60 degree. This question can be solved by two ways, right? One way, the condition for collision is that, right, their perpendicular velocity, suppose this is U1 cos 60, this is U1 sin 60. What is the condition? It will move like this, it will move like this. Condition is that their perpendicular component u1 sin 60 must be equal to u2. So u1 upon u2 is equal to 1 upon sin 60. The answer is root 3 by 2. So u1 upon u2 must be equal to 2 upon root 3. This is the one method. Or the another method is that suppose this is the v1 root 3 by 2 and this is the u1 root 3 by 2 and this is the u1, right, u1 by 2. Is it clear or not? So this is the figure with respect to ground. Now you sit on B, right? So therefore B at rest. Now you are going to make the figure with respect to B and find the relative velocity of A with respect to B. The A has already velocity u1 root 3 by 2 in this direction and u1 by 2 in this direction. B has its velocity. To find the relative velocity of A with respect to B, the ut is transferred to A in opposite direction and this is equal to ut. So listen one thing, A is moving in such a way so that it may collide with the B, right? So it must be moving in a straight line and this is possible only when the no velocity component in the vertical direction. Therefore, u1 root 3 by 2 must be equal to u2 and u1 upon u2 must be equal to 2 upon root 3. So the same method, this is the one method 1 or you can assume this is the method 2, whatever you write. So you can get this. Also, if this distance between them is d, what is the time to collide? The distance upon the relative velocity. The distance is d, the relative velocity is u1 by 2. 2d upon u1 is the time to hit the A with B. All right, copy this. So this example is a little different, right, in which the relative velocity with respect to ground is not given, right? Let's see the question. A person moved due east at a speed 6 meters per second and feels mean the relative velocity of the wind is blowing towards south at a speed 6 meters per second. You have to find first actual velocity of the wind flow. Second, if the person doubles his velocity, then find the relative velocity of wind with respect to man, right? So in this question, listen one thing, the person, suppose this is the east, west, north, south. So velocity of the person is towards east. So I assume this is the x-axis, y-axis. So the person velocity is 6 I cap meter per second and the velocity of the wind with respect to person is given. He feels the wind flows at 6 meter per second in towards south. Towards south mean minus j cap, minus 6 j cap meter per second. You must understand this. So this is the velocity of the person with respect to ground, right? The A point. What you have to find? The velocity of the wind with respect to ground, actual velocity of the wind with respect to ground you have to find. Is it clear or not? So listen one thing. Velocity of, listen, you understand AB vector must be equal to AC plus CB vector. In the same way, the velocity of wind with respect to ground, if it is given, the velocity of wind with respect to person plus velocity of person with respect to ground. This is the vector equation to find this, right, to find the velocity. So velocity of wind with respect to ground we have to find. which is the sum of the velocity of wind with respect to person and velocity of person with respect to ground. So what is the velocity of wind with respect to ground? This is 6i cap minus 6j cap meter per second. What does it mean? 6i mean the 6 meter per second in this way and 6 meter per second in this way. So the wind is blowing in this direction, right? Suppose this is the east, west, north, south. So what is the velocity of the wind? 6 root 2. 6 root 2 towards southeast. Southeast, right? Therefore, velocity of wind is equal to 6 root 2, right? This is 6 and 6. So how to find this velocity? 6 square plus 6 square root. 6 root 2. And this angle will be, definitely this angle will be 45. 6 and 6, right? Tan theta is equal to 1. So it is 6 root 2 meter per second towards southeast, right? Now, in the second part, if the person double its velocity, now the person velocity become double, that is 12 I cap meter per second, and the velocity of the wind remains same. Wind with respect to ground does not change, and it is 6i plus 6j meter per second. And what they are asking in this question? They are asking the apparent velocity of wind with respect to person. They are asking the velocity of the wind with respect to person definitely change. If you change your velocity, right, the velocity of the wind, appeared velocity of the wind will change. Again, I will use this equation, velocity of wind with respect to person, right, is nothing but velocity of wind with respect to ground minus velocity of person with respect to ground. Wind with respect to ground, it is the actual velocity of the wind minus velocity of person. You can solve in this way. So minus 6i cap minus 6j cap, velocity of wind with respect to person. It means now with respect to person, with respect to person, the wind appear 6 meter per second in this direction, 6 meter per second in this direction. When you find the resultant velocity, it is 6 root 2 at angle 45 degree. What is this direction? East, west, north, south. 6 root 2 meter per second, right, in southwest direction. Is it clear or not? So this is the appeared velocity of wind when the person double its speed. Are you getting this thing? So this question we have done with the help of the vector I and j cap, right? So this is the way to solve this question. Copy this. So one more question we will do. In this question, man is going towards east in a car with velocity 20 km per hour and train appear to move towards north to him, right? This is the velocity of the train with a velocity 20 root 3 km. What is the actual velocity and direction of the motion of the train? To do that, this is east, west, north, south, right? What is the velocity of the man? The velocity of the man is 20, right, towards east. That is, if you assume this is the x-axis, y-axis, so this is I cap kilometer per hour, and this is the velocity of the man with respect to ground. Velocity of the train with respect to man, it is given. Train appear to move towards north direction with speed 20 root 3 j cap kilometer per hour. The train is moving in this direction, the person is moving in this direction, right? The train appears mean train with respect to man, and we have to find what? We have to find actual velocity of the train with respect to ground, right? What is the actual velocity and direction also we have to find. Is it clear or not? So again we will apply the same equation, velocity of train with respect to man, right, is equal to velocity of train with respect to man, train with respect to ground plus velocity of ground with respect to man, right? This is the thing, or you may write like this, the velocity of train with respect to ground is velocity of train with respect to man plus velocity of man with respect to ground. It is better to write in this way. Is it clear or not? So, what is the velocity of train with respect to man? Say 20 root 3 j cap plus man with respect to ground 20 I cap. So, this is the velocity of train with respect to ground. That's it. So, this is 20 I cap, 20 root 3 j cap. Are you getting or not? This is the velocity. What is that? This is 20 I cap mean 20 meter per 20 in this direction. This is in kilometer per hour, and this is going 20 root 3 kilometer per hour in this direction. This is the east, west, north, south. So what is the resultant velocity? So the resultant velocity is root over 20 square, 20 root 3 square. 20 is common, root 3 square. So it is 20 into root 4 is equal to 40 kilometer per hour. Is it clear or not? So this is the velocity of the train, right? This is the resultant velocity. This is the velocity of the train with respect to ground, or you can say this is the velocity of the train. So train is moving in this way. Is it clear? And what is this angle? Suppose this is the theta. So what is tan theta? Perpendicular 20 root 3 upon base, it is 20 is equal to root 3. Tan theta is equal to tan 60 degree. The theta is equal to what? Say 60 degree. Is it clear or not? So what will you write? The velocity of train is velocity of train is 40 kilometer per hour at angle 60 degree, right? North of east, 60 degree north of east. This angle must be with the east, or you may write 60 degree towards north from east, right? 60 degree towards north. This angle is what? 60 degree towards north from east. This is the symbol, right? 60 degree north of east. It means the 60 degree is connected with east, right? Copy this.